Hey guys, so today we're going to be doing lesson 3.3, which is greatest common factoring of polynomials. So we've already gone over what greatest common factoring is in a previous lesson, and then the next couple lessons are going to be about factoring polynomials. This greatest common factoring of polynomials is kind of a simplified version of the factoring that we're going to do over the next couple days. Okay, so when you're finding the greatest common factor of a polynomial, the first thing that you need to do is identify what the greatest common factor of each term is. Then we're going to divide each term by that greatest common factor and put the greatest common factor in front of the remaining polynomial. Just a reminder, when we're talking about terms, a term is anything that is separated by a plus sign or a minus sign, not by multiplication or division. We should always combine like terms when possible, which are just terms that have the same variable and the same exponent, or terms that are constant. So for example, if you were given this polynomial here, the first thing I want to do is gather my like terms. So I'm going to get all of my x squareds together, then my x's, then my constants. Because there's no equal sign in here that we're going to be moving things from one side to the other, we do not have to use opposite operations. We only use opposite operations if we're moving from one side of the equal sign to another. So I can just grab a term and move it. So I'm going to keep my 4x squared where it is, and then I'm going to grab my positive 2x squared and put it in behind. Then I'm going to get my x's, so I have my plus 3x, and then my constants at the back. So now these are like terms, my 3x is by itself, and my constants are like terms. And then I just simplify that by adding or subtracting them together. So 4x squared plus 2x squared is, of course, 6x squared, then my plus 3x, and then positive 5 plus 7 is 12. Now from here, I can look at these and say, okay, what is the greatest common factor of 6, 3, and 12? So what I'm looking for when I say the greatest common factor of those is what is the biggest number that I can divide 6, 3, and 12 by? And in this case, the greatest common factor, and you don't have to write it off to the side, but just to emphasize for you guys, the greatest common factor is 3, because I can divide 6 by 3, I can divide 3 by 3, and I can divide 12 by 3. It's the biggest number that I can divide those all by. So I'm going to put my greatest common factor out front of the polynomial, so I'm going to put it out here. And then to get my remaining polynomial, which will go in brackets, I just divide each of these terms one at a time by my greatest common factor. So 6x squared divided by 3, I just do 6 divided by 3, which is 2, and I keep my x squared. 3 divided by 3 is 1, and I keep my x. I could just write just an x here if I wanted instead of 1x. And then lastly, positive 12 divided by 3 is, of course, positive 4. So this would be my final answer. My greatest common factor out front, my remaining polynomial has all been divided by that greatest common factor. Okay, next we're going to try it again, but our greatest common factor isn't just going to be a number, it's also going to include some variables. So in this case, I have negative 20x to the power 4y minus 30x cubed y squared minus 25xy. So when I'm looking for my greatest common factor, again, I'm going to start by looking at the numbers, and I'm going to see what's the biggest number that I can divide negative 20, negative 30, and negative 25 by. And so in this case, my greatest common factor is going to be negative 5. You could also say 5, but we would rather have our negative out front than have all of these negatives inside our remaining polynomial. So when your original polynomial has 2 or more negatives in it, if the majority of the signs are minus signs instead of add signs, your greatest common factor is going to be negative. Then I'm going to look at the letters. So I've got x to the power of 4, x cubed, and x. What is the biggest number of x's that I can remove from each of these terms? And the answer is just a single x, because I can only remove one x from this last term. So my greatest common factor for my x's is just 1x. And then for my y's, again, I have a single y here, a y squared, and then another single y. So the first term and the last term only have one y, so I cannot remove more than a single y. So I only have a single y as my greatest common factor there. Okay, and then I'm going to put that greatest common factor out front. So negative 5xy. And my remaining polynomial will go in brackets. To figure that out, I start with my first term here. I do negative 20 divided by negative 5, which is 4. X to the power of 4 divided by x. Remember, when we have variables like this that we're dividing, we just subtract their exponents. And if there's no exponent, then really there's an imaginary 1 there. So I'm doing x to the power of 4 divided by x to the power of an imaginary 1. So I do 4 minus 1 leaves me with x to the power of 3. And then y divided by y, those can just cancel right out, because it's essentially 1 minus 1, which is y to the power of 0, which we don't have to bother writing in. Then we go to our next term, negative 30 divided by negative 5, which is positive 6. X to the power of 3 divided by x to the power of an imaginary 1. Again, I just keep my x and do 3 minus 1 is x squared. And then for my y, I have y squared divided by y to the power of 1. So I keep my y and do 2 minus an imaginary 1, leaves me with just an imaginary 1. And then the last term, negative 25 divided by negative 5 is positive 5. X divided by x cancel out. Neither one has an exponent. And y divided by y cancels out. So that is my final answer. If you want to check that you have found your greatest common factor and factored it out properly, you can always check by expanding, where you just multiply the greatest common factor back into the polynomial. So let's look at what that would look like. So if we go over this top example here, I got that the answer was 3 times 2x squared plus 1x plus 4. If I want to check that that was right, that I factored this polynomial properly, I can just multiply this 3 back into each of the terms in the polynomial. So 3 times 2x squared is 6x squared. 3 times 1x is 3x, and 3 times 4 is 12. And as long as this answer here matches this polynomial that I factored up in the previous question, that tells me that I did my factoring correct. So you can always double check your work like that. It's a really good idea to do that on a test or quiz if you have time. So yeah, that's greatest common factoring. We will be building on this tomorrow, so please let me know if you have any questions.